A series of earthquakes shook the region of Brawley, California, just after midnight this week, with the strongest measured at magnitude 3. 6. And that was not the main shock, because there was no main shock. That is the signature of a swarm. And this one woke up at precisely the worst possible address in Southern California, the doorstep of the southern San Andreas, the fault that has been silent for more than 300 years. Within the next hour, another seismic event shook the region. A 3.4 magnitude tremor struck at 1:49 a.m., according to the USGS, with the epicenter located at the same location, at a depth of 16 kilometers. Most swarms here fade to nothing. The same ground did exactly this back in May. And I am going to show you precisely what scientists are watching right now to know which way this one goes. Let's start with what actually happened and what it means. The Brawley Seismic Zone sits in Imperial County, one of the busiest patches of crust in California, roughly 115 miles east of San Diego. The jolts are concentrated around the Brawley Fault Zone, an area known for frequent earthquake swarms connecting the Imperial and San Andreas faults. But to understand why any swarm here gets more attention than a swarm almost anywhere else in the state, you need to understand what a swarm actually is, and specifically why it is not the same thing as a normal earthquake sequence. When most people picture an earthquake, they picture one big jolt followed by a string of weaker aftershocks that fade over hours and days. That is the standard script. A swarm does not work that way. A swarm is a group of quakes, dozens to thousands, where there are many earthquakes close in size and no obvious main shock. The 3. 6. That led this week's sequence was not a main shock, it was just the biggest so far. What drives a swarm is fundamentally different from what drives a conventional earthquake sequence. A conventional main shock is a stress problem. The crust builds up strain until a fault snaps. A swarm is usually a fluid problem, water and sometimes magma migrating through cracks in the rock, changing the pressure on small faults and letting them slip a little at a time. That is why swarms ignore the usual statistical decay patterns. They can stall completely and then restart without warning because the thing pushing them is fluid moving through a fractured system, and fluid can stop and start. That distinction carries one very practical consequence. In a normal sequence, once you have had the big one, the worst is statistically behind you. In a swarm, you do not get that reassurance because there is no main shock to put in the rearview mirror. The largest event might already have happened, or it might still be coming. Now let's put this week in context by looking at what this same piece of ground did less than 3 months ago. Residents near Brawley reported feeling strong shaking from the 4.7 magnitude earthquake that struck on May 9th, 2026, while residents in El Centro, Calexico, El Cajon, Poway, Chula Vista, and more reported feeling weak to light shaking. The U.S. Geological Survey recorded 353 earthquakes in the past day, as of just before 10 a.m. Sunday in the immediate Brawley area in Imperial County. The 4. 7 magnitude quake struck around 12:10 a.m. Sunday, a little under 2 miles west-southwest of Brawley, with a depth of about 9 miles. Foreshocks started around 3 a.m. on Saturday. The California Governor's Office of Emergency Services said it had been keeping an eye on the situation. So far, no major damage or injuries were reported. 353 earthquakes in a single day. A 4. 7 fell from San Diego to the U.S.-Mexico border. And the same zone is now producing another sequence less than 3 months later. That repetition is the detail most worth understanding, because it tells you exactly what kind of geological machine you're dealing with. Experts believe the Brawley Seismic Zone is prone to these earthquake swarms due to its proximity to a lot of geothermal activity. Several volcanoes, like Salton Buttes, just a few kilometers to the north, are indicative of that. Lucy Jones, a seismologist with Caltech, said the phenomenon is not unusual for the region because of its geological makeup. Instead of having one big fault, there's a lot of small crossing faults, Jones said. Probably hundreds of times we've seen swarms like this. Hundreds of times. That is not a warning. That is the baseline. The Brawley Seismic Zone swarms constantly. It has been doing this for as long as instruments have been watching it. What makes any given swarm worth examining carefully is not the swarm itself. It is the address. And this address has a very specific and very serious structural meaning. The quakes have been centered in between 2 major fault lines, the infamous San Andreas Fault and the Imperial Fault Zone. That area is referred to as the Brawley Seismic Area on fault maps, published by the California Department of Conservation. The Brawley Seismic Zone is not a random patch of active ground. It is a transfer zone, a geological junction box. It is the place where the northern end of the Imperial Fault hands the plate motion off to the southern end of the San Andreas Fault at the bottom of the Salton Sea. When the Brawley Zone shakes, it is shaking right at the base of the San Andreas, and the specific stretch of the San Andreas that begins here is the one that keeps seismologists up at night. This is the southernmost San Andreas, the section that runs along the northeast shore of the Salton Sea, past a small community called Bombay Beach, and up toward the Coachella Valley and greater Los Angeles beyond it. That section has not produced a major earthquake in at least 300 years. The chronology of its past ruptures, worked out from trenching across the fault and dating the disturbed layers, shows a fault that, on average, tears loose roughly every 180 years. Do that arithmetic, and this section is not just due. It is well past due. So when a swarm fires off right at the connection point to that fault, the question writes itself. Could the small earthquakes at the doorstep give the sleeping giant next door the nudge it needs to finally wake up? Experts told News Channel 3 that the swarm activity has been decaying since the swarm started over the weekend. And even though there is a non-zero chance seismic activity in that area could jump to the San Andreas Fault, that chance remains low. Now, the interesting thing about this swarm and many of the swarms in the Brawley areas, they actually go perpendicular to those two faults. So there may be almost more structure that might connect between the two faults, or really get to be a complication between the two faults, revealed Andy Michael, a geophysicist with the U.S. Geological Survey who has been tracking the latest swarm in Brawley. Even at magnitude 4.7, Jones doesn't believe the swarm will set off the San Andreas. Well, aftershocks don't have to be on the same fault, but it has to be close enough that the stress change that produced the first earthquake can make it there, Jones said. That framing from Jones and Michael is the honest scientific answer. The mechanism for stress transfer is real but constrained by distance and magnitude. A magnitude 3 or 4 changes the stress on surrounding faults, meaningfully only within a few kilometers. This week's swarm is roughly 60 kilometers south of the San Andreas terminus at Bombay Beach. That is close enough to keep the question alive in the scientific literature. It is far enough that the actual stress being added to the San Andreas is small, much smaller than what would be added if the swarm were occurring at the terminus itself. The most relevant comparison in the historical record is the September 2016 Bombay Beach swarm. That sequence broke out directly at the southern tip of the San Andreas, not 60 kilometers away, but right on top of it. Because of that proximity, the USGS ran its real-time probability calculations and publicly raised the estimated odds of a magnitude 7 or greater earthquake on the southern San Andreas over the following week to as high as 1 in 100. For context, the normal background odds in any given week are somewhere around 1 in 6,000, a 100-fold jump. The California Office of Emergency Services issued a formal earthquake advisory, and then nothing happened. The swarm faded, the odds decayed back to background within the week, and the advisory quietly lapsed. That is not a failure of the science. It is the science working exactly as designed. A 1 in 100 chance means 99 times out of 100 nothing happens. 2016 was one of the 99, but that episode established the most important single fact about how authorities respond to swarms in this zone. When the odds go up, they say so publicly and immediately. The idea that agencies secretly know when the big one is coming and are withholding that information runs directly into the 2016 record, where they raised the alarm in real time over a swarm smaller than what this zone produced in May. There's a genuine scientific mystery sitting underneath this whole story, and it deserves careful attention because it is the thing that should actually hold your attention long after this particular swarm fades. The noisiest patch of crust in Southern California sits directly at the foot of the quietest major fault in California. Constant hum at the doorstep. Total silence on the main fault. Research published by Hill and colleagues found something remarkable about the history of that silence. The last several major ruptures of the southernmost San Andreas each lined up with times when an ancient lake called Lake Cahuilla, far larger than today's Salton Sea, was full. The weight of all that water and the pressure it pushed into the ground may have been acting like a trigger, helping the fault let go on a more regular schedule. The lake has been essentially gone for centuries. The modern Salton Sea is a shrinking remnant of it, and that may be exactly why the fault's clock appears to have slowed down. Here is the unsettling implication of that idea. If the lake was helping the fault release strain on time, then losing the lake did not make the fault safer. It just removed the trigger. The strain has kept accumulating the whole time. Several meters of stored strain are now locked in that section of fault with nothing to help it release. The silence is not peace. It is a loaded spring with the safety stuck on. While most of the responses to this week's sequence were submitted near the epicenter in Brawley, people in locations such as Holtville, 22 kilometers from the epicenter, and Heber, 20 kilometers from the epicenter, also reported feeling the quakes. The earthquakes occurring at shallow depths typically cause more intense and noticeable shaking than quakes that occur deeper. No damage, no injuries. That is consistent with what the May swarm also produced, despite its far larger scale of 353 earthquakes and a 4.7 magnitude peak. The area is part of the Brawley Seismic Zone, which has a history of earthquake swarms and geothermal energy exploitation, the USGS explains. It's also near the Brawley Fault Zone, considered a complex set of faults that is intricately connected to the Imperial Fault Zone. It is also worth noting what the real proven hazard around here looks like, because it is not the swarm itself. the faults the Brawley Zone connects to have a documented history of genuinely destructive earthquakes. The Imperial Valley produced twin magnitude 6, 2 shocks an hour apart in 1915. The El Centro earthquake of 1940 reached magnitude 6, 9 on the Imperial Fault. 79 brought a magnitude 6, 5 to the same valley. 1987 delivered a magnitude 6, 5 at Superstition Hills. And in 2010, the El Mayor Cucapa earthquake just across the border in Mexico hit magnitude 7. 2, those are the events that actually damage buildings and hurt people. The swarm is the noisy symptom. Those faults are the real reason anyone in this valley keeps an earthquake kit ready. Now let's talk about the specific things scientists are watching right now to tell them whether this week's activity is noise or the opening of something more serious. These are concrete and checkable, not vague. The first is magnitude. If the swarm climbs past May's peak of magnitude 4. 7, especially if it pushes toward the historical swarm ceiling for this zone of around magnitude 5. 5, that changes the risk picture. A magnitude 5.5 releases roughly 700 times the energy of a 3. 6, the event climbing rather than fading is the first red flag. The second is direction. Watch where the earthquakes move. City leaders at Brawley say they continue closely monitoring ongoing earthquake activity and aftershocks affecting the region. If the activity stays put beneath Brawley, that is the reassuring case. If it starts migrating north, toward Westmoreland, toward the geothermal field, and above all toward Bombay Beach and the San Andreas terminus, that is the scenario that matters. That is the direction that would carry the swarm from 60 kilometers away to right on top of the fault and into 2016 territory. Location is everything with this hazard, and northward migration is the single most important thing to track. The third signal is official. If the USGS issues a formal aftershock forecast, or the state issues an earthquake advisory the way both happened in 2016 and again during a 2020 swarm at Westmoreland, that is the cue that the professionals have run the real-time numbers and decided the odds have moved enough to say so publicly. You will not have to guess. If that threshold gets crossed, they will tell you openly, the same way they did in 2016. The single most probable outcome by a wide margin is that this week's sequence behaves exactly like May did, and like every previous Brawley swarm before that. It rises, rattles, and fades out over the coming days without producing anything larger than a moderate earthquake. If you live in the Imperial Valley or surrounding areas, the realistic thing to prepare for is a few more restless nights and continued minor shaking. Not a catastrophe. But the reason this is worth watching carefully is not the swarm. It is the fault next door. The southernmost San Andreas, silent for more than 3 centuries, loaded with several meters of stored strain, sitting 60 kilometers from a patch of ground that will not stop trembling. Even though there is a non-zero chance seismic activity in that area could jump to the San Andreas Fault, that chance remains low. Low is not zero. And the 3 things worth tracking: whether the earthquakes get bigger, whether they march north toward the terminus, and whether the agencies issue a formal advisory, are your real-time signal system for knowing when the assessment changes. Until one of those 3 things happens, this stays what it most likely is. A noisy week at the doorstep of the most heavily loaded section of the most famous fault in America. The doorstep that has been trembling for as long as anyone has been measuring it, right next to a door that has not opened in more than 300 years.